Okay, everybody. So, eyes up front, eyes up front. We are talking about atmospheric pollution today. So before we can do this, we need to know what is air pollution. So I went through the notes and I tried to make them as concise as possible because I know last unit was very heavy on the notes. And so on those slides that don't have like blue writing in the note area, just listen to make sure you understand the big ideas that are going along. So what is air pollution? Air pollution occurs when the air contains gases, particles, or fumes in concentrations that endanger health of organisms and function of the environment. So it's only considered pollution if what's in the atmosphere is harmful to the environment. A big thing to understand or to know is that air pollution is not the same as climate change. They can be related to each other, but they are not the same thing. So pollution does not necessarily lead to climate change, but it impacts the composition of the atmosphere, but it may or may not impact the climate itself. So why do we care about air pollution? Is there anybody in here that has asthma or like a breathing condition where if the air is really bad outside, it makes it really hard to breathe? Yeah, like one of my best friends has that. And so whenever we have an orange or a red air day, it's really, really hard for her to breathe. So not only are those people susceptible to air pollution and what's happening, but if you think about it, we use more air than we use any other thing in our body daily. So if we look, we use about 13.5 kilograms of air each day, where we only use 1.7 and 1.2 kilograms of food and 2 kilograms of water. So we use a lot more air than we use anything else into our body. And so you definitely would not eat a McNugget if it was on the ground run over by a car, right? At least I hope you would. I know you guys are teenagers and like sometimes there are extreme circumstances, but hopefully you wouldn't. Hopefully you would be more concerned about the quality of your food. So we need to be concerned about the quality of our air because we use more air than we use actual food. So let's talk about air pollutants. What are air pollutants? Air pollutants can be broken down into two different categories, either primary pollutants or secondary pollutants. So we're going to start with primary pollutants first. So primary pollutants are pollutants that are emitted from an identifiable source. So we know that these pollutants are coming from a car, or they're coming from a factory, or they're coming from an oil spill. So you know exactly where they are coming from. Inside of primary pollutants, there's also two separate categories. We have point source pollutants and we have non-point source pollutants. The difference between non-point source and point source is being able to pinpoint exactly where it comes from. So, point source pollution is any single identifiable source of pollution. So like a stationary source, an area source, a mobile source, or a natural source. So we know exactly where the pollutant is coming from. Whereas a non-point source pollutant is a non-identifiable source of pollution. So pollution is happening. We know generally what's creating it, but we can't pinpoint exactly what it is. So my favorite way of explaining this is a little bit embarrassing, and this is why my kids are never going to want to come to Skyridge because I'm going to embarrass them way too much. So imagine that you are on a road trip, and it's just you and one other person, and somebody in the car farts. Do you know who farted? Yes, because either it was you or it was not you. And if it was not you, it was the other person. Like, there is no questioning where that fart came from. So that would be an example of like a point source pollution, where it's a single identifiable source of pollution. Now let's think if we were on a school bus and you were going on a road trip and somebody farts. Can you identify who the farter is? No, right? I mean, unless it's you. But like, it's gonna be hard. You know somebody farted, you know what it is, but you don't know who it was. So that's gonna be an example of a non-point source pollution, where you know what the pollutant is, you know that it came from something that was combusting something, but you can't pinpoint exactly what the pollutant or the supplier of the pollution is. Then next we have secondary pollutants. So secondary pollutants are pollutants that are produced in the atmosphere from the chemical reaction of primary pollutants. So this means that when two pollutants fall in love and they make a baby, that's what secondary pollutants are. Where you have two chemicals in the atmosphere and they go through a chemical reaction together and they create a new pollutant. So something that was not emitted in the first place. So, like it says, pollutants produced in the atmosphere from the chemical reaction of primary pollutants. And the way that this usually happens is by photochemical reactions. So the sun is really, really powerful, and it creates an environment where these chemical reactions can happen. So without the sunlight, we wouldn't be able to have these chemical reactions. We wouldn't be able to have this type of pollutant emitted. So it's a chemical reaction in the atmosphere triggered by sunlight. So what I'd love for you guys to do is as soon as you're done writing this down, so no rush, I would love for you to turn to somebody next to you and have one of you guys choose primary pollutants and somebody choose secondary pollutants and go through and explain it yourself. So turn to them and explain to them what a primary pollutant is and what a secondary pollutant is. Go ahead and go. So primary and secondary pollutants, huh?
Yes.
We did. Tú no sabes, right? For secondary, you don't know.
Tú no sabes para
No,
la
it
primera.
is. That's your turn.
And secondary.
Primary is it's a detectable source.
Yep, absolutely.
Yeah, we said that.
Perfect. All right, let's bring it back together in 3, 2, 1. All right, so sticks of destiny, prepare yourselves. All right, so let's see. The first person who I pick their name, you can choose whatever you want to talk about. You can either talk about primary pollutants, point source pollutants, non-point source pollutants, secondary pollutants, or photochemical reactions. Don't read it off the screen. You can use the screen as a note, but you have to put it in your own words, okay? So this one is going to go to Ridge. Okay, what do you want to talk about? Okay, pick one. Yep, anyone. Okay, what is a primary pollutant? Perfect. So it's a pollutant where we know it comes from a specific source, right? If you're talking, please stop. Okay, Darian, you get the second one. So what? He did primary pollutants, so you can pick anything besides primary.
Secondary is when two primaries make a different one.
Perfect, yeah, that's exactly what it is. So secondary pollutions are two primary pollutants come together and create a brand new pollutant. All right, this next one's gonna go to Evie. Okay, so you can either do point source pollutants, non-point source pollutants, or photochemical reaction. Which one do you want to do? Okay, photochemical reaction, go ahead and do it.
It's basically when the sun is like the reason for the chemical reaction that creates a secondary pollutant.
Stop talking. Yep, exactly. So, it's where a chemical reaction happens, right? Creates a brand new one. All right, so now we're gonna go to not here. Addie. There you are. Okay, so you can either do point source pollutants or non-point source pollutants. Which one do you want to do?
Non-point source.
Okay, perfect. What's a non-point source pollutant?
Can't identify where it came from.
Perfect. So we know that it comes from like a specific kind of source, but we don't know which one it came from. Absolutely. All right, last but not least, this one is going to Lily. There you are. Okay, so point source pollutants. Perfect. So we know exactly where it came from, right? Very identifiable, which is good to know. Okay, so moving on. We're going to talk about the main sources of pollution in our atmosphere. So the first one is sulfur dioxide. So if I were you guys, I would title it sulfur dioxide and then write when coal is burned, it releases it. So sulfur dioxide is most commonly created by burning coal or by burning diesel fuel. So sulfur dioxide is not great, and the reason that it's not great is because it has a tendency to create acid rain. So when the sulfur in the sulfur dioxide goes into the atmosphere, it reacts with any kind of water vapor and it creates sulfur hydroxide. So sulfuric acid or sulfur hydroxide. So this is a big problem because one of the main or most commonly uses of energy is coal, like we talked about last unit. So coal when burned releases sulfur dioxide, toxic metals, and particulates. These are harmful in their own ways as seen below. So sulfur dioxide is a corrosive gas that is common, which comes primarily from the combustion of coal. It is a respiratory irritant and can affect asthma and other respiratory conditions. It is also known to harm the stomata of other plant tissues. It can also be converted to sulfuric acid in the atmosphere and can harm aquatic life. So sulfur dioxide was the first one we talked about. Now we are going to scroll down and talk about particulates, which is also something that coal can create when it is burned. So particulates are solid or liquid particles that are suspended in the air. So basically anything that is not a gas that is in the atmosphere is a particulate. Yeah, so basically anything in the atmosphere that is not a gas is a particulate. So it's any kind of solid or liquid suspended in the air. Yeah.
Does that include rain?
So it would include like fog. So like because rain's not suspended in the air, it's falling. So it'd have to be something that's like actually sticking around in the air. Like humidity kind of would be considered particulates. Only if the cloud was close to us.
Okay.
Yep.
So
Like a fog. Yep. Oh, it is not scrolling up for you guys. Sorry. There you go. Sorry. So particulate matter comes from the combustion of wood, bioproducts, and coal. Particulates are a great health concern because they can travel further within the respiratory tract and they tend to be composed of more toxic substances. They can also scatter and absorb sunlight, and this can affect the rate of photosynthesis. All right, next we're going to talk about metals. So all metals in the atmosphere are toxic to the central nervous system. And if you don't know what the central nervous system is, the central nervous system is your brain and your spinal column. So very important things for you to, do your daily stuff. So when a lot of metals are found in the air, they tend to attack humans and cause adverse effects. It also can bioaccumulate in the food chain. So you talked about bioaccumulation a couple of units ago. Does anybody remember what bioaccumulation is? Yeah, Lynette.
Isn't it when one thing is poison and then the next thing eats it and they carry that poison to the next thing?
So close. So that's biomagnification.
Oh.
So bioaccumulation is a little bit different, but they go hand in hand. All right, so bioaccumulation is like this. So here is my drawing. Ready for this? It's pretty great. So imagine we have a fish tank, and we have 2 fish in it. Oops. Beautiful fish. Okay, so this fish is only going to be in the fish tank for 1 day. this fish is going to be in the fish tank for 30 days. So if we were to take a pollutant and put it in the fish tank, which we'll say is the red stuff, which fish is going to have more pollutant in their body? The fish that's in there for 1 day or the fish that's in there for 30 days?
30.
Perfect. That's bioaccumulation. So bioaccumulation means that the more you are exposed to it, the more you actually absorb. And it's harmful, like Lynette said, because when that happens, it can go up through the food chain, which means that it affects us. Because we are at the top of the food chain, right? We eat basically everything below us. And so if we are getting these toxic metals into the lower parts of the food chain, as they move up the food chain and as they biomagnify that way, it's going to be a really big harm for us as humans. So another one we're going to talk about is NOx, or nitric oxide. So NOx is released from burning fossil fuels. So NOx is really bad because it's a respiratory irritant, which means that it makes our lungs not feel great when we breathe it in. It makes it easier to get infections, but it's also an ozone precursor, and that's the biggest thing I want you guys to remember, because we're going to be talking more about this as we move on and talk about inversions and smog. Because ozone is great if it's in the troposphere, not so great if it's in, reverse that. It's great when it's in the stratosphere, not so great when it's in the troposphere. So just to kind of remind you about stratosphere, troposphere, and the layers of the atmosphere. So here is our Earth, right? Here is the very first layer closest to the Earth, and this is the troposphere. On top of the troposphere, we have the stratosphere. In the stratosphere is where we find the ozone layer, right? So the ozone layer is really important because it blocks out UV rays, which means that we don't get cancer. So yay for the ozone layer. However, if we have ozone in the troposphere, it turns into smog, and it's really not good for us. So ozone where it belongs in the stratosphere is great. Ozone close to us is really, really dangerous. Another thing that can produce sulfur dioxide is diesel fuel, but we already wrote that down. So if you feel confident knowing that diesel fuel produces sulfur dioxide, you're welcome to skip this. So because all these pollutants and because we were aware of these pollutants, the United States decided that we needed to do something about it. So we created something called the Clean Air Act of 1970. Any guesses on what year it passed?
1970.
What? Oh my gosh. So smart. Can't even believe it. So 1970, it identified 6 pollutants, right? 6 pollutants, and these are the pollutants that we just barely talked about, right? So we talked about sulfur dioxide, we talked about nitrogen oxide, we talked about particulate matter, tropospheric ozone, and lead. The only one we haven't talked about yet is carbon monoxide. Carbon monoxide, we all have carbon monoxide detectors in our houses, which sometimes are not the most effective because manufacturers tend to put carbon monoxide in smoke detectors, but carbon monoxide is actually a really heavy gas, and so it's going to be sinking to the bottom of the floor and not up by the smoke detector itself. So by the time it gets up to the smoke detector, you're already dead. So not the greatest design there, but so carbon monoxide is dangerous because we know that the red blood cell accepts oxygen and pushes it through our whole entire body, right? You breathe oxygen into your lungs, the red blood cells get pumped to your lungs, it picks up the oxygen, drops off the CO2, and brings oxygen to the rest of your cells, which is super important. However, carbon monoxide loves red blood cells. Like, it binds onto a red blood cell and will not let go, which means that there's not any space for oxygen to bind to your red blood cells, which will cause you to suffocate. So that's why carbon monoxide is so, so dangerous. So we are really concerned with these 6 pollutants. Again, they are sulfur dioxide, nitrogen oxides, carbon monoxide, particulate matter, tropospheric ozone, and lead. However, we found that in 2007, when you guys were all, you guys were probably 1 or 2. Was anybody born in 2007? Oh my gosh. I was in 7th grade, so this is just like super fun for me. Anyways, so in 2007, your guys' birth year, the U.S. stated that CO2 should also be considered an air pollutant, and it was added to the Clean Air Act. So not only do we have the original 6, but now we have 7 air pollutants in the Clean Air Act of 1970. So if you're trying to remember how many pollutants you need to remember, you can think 1970. There are 7 pollutants that are being focused on. Yeah?
Have they always been in our air, or are we finally like figuring out what they are?
That's a good question. So particulate matter can come from natural sources. NOx can come from, not NOx, sorry, carbon monoxide can come from natural sources, but sulfur dioxide, nitrogen oxide, tropospheric ozone, and lead are all things that us as humans are putting in the atmosphere.
So how long have they been?
Ever since we've been using industrial stuff. Yep. All right, sounds like you don't need this one anymore, so we're going to move on.
What? He's so new to me.
Okay. So we're going to talk about one other thing before we start talking about, before we watch a movie. So photochemical smog. Yes, sir. I know. This is the last slide of the day, so I believe in you guys. You can do it. So, photochemical smog is a secondary pollutant, which means what? Somebody remind me what a secondary pollutant is. Yeah.
It's a combined chain of 2 pollutants.
Perfect. So it's 2 pollutants that have come together and changed into something else. So photochemical smog or ground level ozone, remember ozone in the troposphere is terrible. We don't like it. Is produced when sunlight reacts with nitrogen oxides or NOx and VOCs or VOX. So it kind of sounds like a Dr. Seuss thing. We got VOX and NOx in SOX and VOX. So these 2 things come together. We know that NOx or nitrogen oxides comes from cars. So cars produce NOx, it goes into the atmosphere, and then VOX or VOCs are called volatile organic compounds. So these are things that can either be naturally occurring or they can be man-made. Basically, anything that gives off a strong smell is going to be a VOX. So that could be pine trees, that could be carpet smell, it could be the smell of gasoline. Anything that gives off a strong aromatic smell that is organic, meaning has carbon and is associated with life, can produce a VOC or a VOX. So, photochemical smog or ground level ozone is produced when sunlight reacts with nitrogen oxides and at least 1 volatile organic compound or VOX in the atmosphere. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions, whereas VOX are released from gasoline, paints, and many cleaning solvents. When sunlight hits these chemicals, they form airborne particles and ground level ozone or smog. So if you look right here, I can guarantee that you guys have seen this when you go past the point of the mountain. You go on the point of the mountain, you look to Salt Lake City, and you can see this brown haze just kind of being in the valley. And that's what it is. So it is a photochemical reaction or the production of a secondary pollutant due to the 2 chemicals, VOC and NOx, reacting with sunlight. So after you're done writing this down, we're going to stop here today because we're going to talk more about smog and inversions next time as we do our car lab and we actually capture car exhaust and we look at what it contains and what particulate matter comes from it.
Cleaning solvents.
Cleaning solvents, so like think of Windex or like any kind of chemical cleaner.